Good afternoon. My name is Sir Arthur Eddington. I was born in Kendal, England in 1882. My father was a headmaster at the Quaker school and moved to Kendal to become the headmaster at Stromingate. He died when I was only 2 years old, so my mother was left raising me and my brother. We didn't have much growing up, but when I got to school, I was pretty good at mathematics and English. I received a scholarship to Owens College in Manchester, England. I received my bachelor's in physics with first class honors in 1902. I then received a scholarship to Trinity College in Cambridge. I received my master's in 1905. My colleague E.T. Whitaker gave a recommendation, and I secured a position at the Royal Observatory in Greenwich. Around the same time, Albert Einstein was finishing up his ideas on the theory of general relativity. Many of my British colleagues couldn't put aside their pride and consider the ideas of a German to be true. I decided to conduct some experiments to help prove his theories. Einstein had three major concepts that if any of them could be proven false, then the whole theory would fall apart. One of this was that light could be bent by gravity. After thinking about it for some time and discussing it with some of my partners, I knew exactly how to test this theory. Einstein completely changed the way that we view the effects of gravity of other objects. It was much different from Newton's laws, which had been accepted by the world for almost 200 years. Newton claimed that light could bend passing a massive object. Einstein's theory said it could bend twice as much. Gravitational lensing is part of his theory that we wanted to prove. One way we decided to prove this was to measure the distance between the stars and the sun and compare it to the position when the stars were in line with the sun. The problem is we couldn't see the stars because of the brightness and the intensity of the sun. However, there was a total solar eclipse coming in May of 1919. This would be the perfect time to perform these tests because the sun would be blocked by the moon. I noticed that the highest star cluster would be near the sun during the eclipse, so I took some measurements in the months before the eclipse. While the cluster is a good ways away from the sun, this gave me a good comparison for my measurements. My goal was to find the position of the star cluster while it was close to the sun and to see how much the image shifted based on my initial measurements. The distance would either prove Einstein was correct or that he was wrong and Newton was correct almost 200 years ago. After finding out about the solar eclipse, I had to find where the path would be in the center of totality, giving me the most time to measure the star cluster. I also wanted to be far enough away from other people so that they wouldn't be messing up my experiment. After a little bit of research, I found an island off the coast of Africa that would be in complete totality. This island was called Principe. Just in case the cloud cover was too great in Principe at the day of the eclipse, we had a secondary team set up in Sobral, Brazil. Well, as many times as it does, things went wrong. The day of the eclipse, a huge thunderstorm hit the island of Principe. The Brazilian team had some trouble with the heat, but managed to work through it and get the information that we needed. There was a lot going on around the world at the time we were doing this experiment. World War I was going on and it played a big part in the efficiency of the work that we were doing. Many of my colleagues wouldn't help because the idea was that of a German's. Many people didn't want to get behind my work because of the situation with the war. Luckily, the war ended a few months before the eclipse happened, which allowed some people to join the team and help with setting up for the day of the eclipse and help gather the information that we needed. My main partner in this experiment was Einstein himself. The way he understood how the universe worked was remarkable, and I was truly amazed at how incredible his mind really was. When I worked at the Royal Astronomical Society, I was one of the ones who got to look at his papers and writings concerning his new findings. One of my colleagues, William D. Sitter, a Dutch physicist, was the one who first sent me documentation of Einstein's findings. He knew that I would appreciate the information just as much as he had. There were many other people that helped in making the experiment work, but without the ideas of Einstein to set it all in place, none of this would have been possible. My role in this experiment was to help Einstein get the things that he needed to conduct the experiments. He stated that the light would bend when it passes closely by another object. The more massive the object, the greater the gravitational lensing would occur. My job for the experiment was to calculate how much the light from the highest star cluster shifted during the eclipse. I supervised over my team, making sure we got enough measurements and pictures during the time of the total eclipse. Once we had gathered all the data, I did my calculations and found the results. I then publicized my results and made it known that we had confirmed a part of Einstein's theory. The results changed the physics world a great deal. Einstein's theory of general relativity made us look at the world in a totally different way. His discoveries unearthed a completely new interest in many other physics-related questions. He also opened the eyes of many people that Newton had been wrong with how gravity worked, and that some of Newton's theories were also incorrect. Since Einstein was right, it allowed us to study and experiment with more things in outer space. His idea of gravitational lensing will be used for years to come for looking at the planets outside of our solar system. We can use the idea of light bending around a massive object to use as a reference point to look for some of those planets based on the displacement of the stars. Not everyone was a firm believer of Einstein's theories in our research. I threw out some of the data because in Brazil the heat had warped the telescope. I didn't want this to skew our data, so I threw it out. You can rest assured that everything we did was accurate and honest. Many people since our experiment have conducted similar experiments, and time after time the data speaks for itself. I'm going to say yes or no on that question. Yes, because it filled up much of my time. If I was not working on research, I was writing a book or giving lectures. One of my favorite lectures I gave was at Cambridge. I used the information I gave during the lecture to write one of my books, Mathematical Theory of Relativity. It's available downstairs. However, as a result of the project, my life also didn't change that much, because I still spent most of my time doing research. It just shifted to different things.